Assalamu alaikum. My name is Dr. Saqib Iqbal and welcome to lecture number 10 of software construction. Today's topic is frameworks, and before going on to the frameworks, I want to repeat what we did in the previous lectures. Actually, so far we have studied about classes, objects, interfaces, abstract classes, and we have also studied some features of classes when you are going to implement them. There are many types of classes. One of them is interfaces, which you do when you are going to implement a particular type of contract in your system. And then there is another one, which is abstract class, when you are designing a system and you want to look at the overview of the system. You don't want to go into the details, then you adopt abstract classes. And abstract classes are also useful when you are implementing inheritance, when you are going to have reusability in the code, when you don't want to repeat the code in multiple classes. So what you do is that you keep them in the superclasses and use them in the subclasses. And there is another one which is related to inheritance and abstract classes, and that's polymorphic behavior of the classes, in which you declare multiple classes with the same signature, and you declare multiple methods with the same name and signature. So what it does is that it provides you capability of using different methods at the same time with one object. And so that was the classes. There were some keywords which we also studied. One of them was the final keyword, and which is used to make constants, and which is also used to avoid the overriding of methods. And there is another keyword which is called static, which we use to implement class variables and class methods. And whenever you require such a method to declare, which is shared by multiple objects, you make it static. So what happens is that the values in the static methods cannot be changed, and it cannot be overridden in the subclasses. So that was all about classes. We also studied that how you instantiate the object and how you initialize it in the beginning. We also studied that there are ways to make constructors, there are ways to make overloading of the methods when you have got different methods with same signature but different parameters. So these are the different types of classes which we studied, and that's the core object-oriented concepts which we covered in the previous lecture. Now if we take it further, then when you are going to implement the classes, I showed you some example in the previous lectures as well, like how you write the code of abstract classes, interfaces, and inheritance. But there is another one, there is another thing which you can adopt, that's called frameworks. Frameworks are just like tools. I think you must have practiced on Eclipse tool and JBuilder tool, which have got IDE to write Java code. But framework is slightly different from Eclipse. What it does is that it provides you control on building a software. It provides you with different already executed applications which are embedded in the frameworks. So what it does for you is, like, during the execution time, you can use those applications at the runtime, and you don't have to worry about them because the tool which you are using does it for you. So in frameworks, what we're gonna do is that today we're gonna cover these topics, in which I'll give you introduction of frameworks and what are the different types of frameworks, how you use them, what are the different tools which you can adopt to work on frameworks. Then there is extensibility, which is one of the features of frameworks, and inversion of control. This is another feature which is used extensively by frameworks. And then we have got Java frameworks, because in the beginning we're gonna cover generic frameworks, but then we will slowly go to we will narrow it down to Java frameworks, because we are working on the Java technology during this course. And then I'll also tell you advantages and disadvantages of Java frameworks. In the reading, what I'm gonna recommend you is to go online and read software framework from Wikipedia. And you can also find a lot of tutorial if you have studied the previous lectures from Java tutorial. They have got some subsections on software frameworks as well. And if you can't find a lot of material in it, then there are always books about object-oriented programming and frameworks itself. And then there is frameworks in Java, because that software framework is generic term, but what you should do is that you should also focus on the frameworks in Java. Okay, so this is what we are going to cover today. And so first of all, let's start with framework. Any generic software platform for a certain type of applications is called framework, which consists of parts that are found in many applications of that type. So basically, in simple words, framework is a software platform. What it does for you is that you do a certain kind of job in the framework. For example, if you are building websites and if you are building any web application for different websites, so you can adopt web-specific platforms which are called web frameworks. And if you are developing a commercial website, there are different kind of frameworks. And if you are going to develop a gaming application, then there are game frameworks available as well. So what do they have is they have libraries with APIs, which are basically the classes with methods. So they are already developed and already compiled classes which have got methods which you can use in your system. If I give you an example from previous lectures, you must remember that we discussed object class, which has got a lot of methods which you can use in any class. For example, I showed you toString or equals methods. In the toString, what it does is that it takes any variable and it converts it into a string one, or it takes all the values of an object and converts them into string. Similarly, we also saw equals, that if you have got two objects which are similar to each other and you want to find if they are similar in nature, then you can use equal method, which will give you true or false if those objects are similar or not. So similarly, we also discussed some of the other methods which are part of object, and of course you can overload them and you can override them in subclasses. And I also told you that object is the parent class of all the classes. Even if you don't declare it explicitly on the parent class of any class, it still is declared as a parent implicitly within the tool. So what happens is that without extending it with any class, you can simply call its methods. And I also asked you to read about object class. It has got so many methods which could be utilized. But the difference between using classes and frameworks is that in the classes you write everything in the class, and then you explicitly call the methods to do job for you. But in frameworks, there are many libraries which have got methods, classes in it, and you can simply use them, or you can opt for that framework to do it for you. What it does is that when your system is running, framework inserts the behavior which you want from that framework during the runtime of the application. So you don't have to explicitly write the code to call any method. These are called libraries, and of course you can also use libraries within your system. You can call those libraries, you can declare them along with your code, and then you call methods from them. And if you want to read about these libraries, there is a lot of material available on the internet. You can go on the on the website of a specific framework, and it can give you information about all the libraries that particular framework has got. Similarly, it has got another part which is called ready-made extensible programs, which are also called engines. So what they do is that they are already developed program, and they're extensible in nature too. Extensible means that you can add some behavior to them, or you can override their methods, or you can add any kind of extra method to it. And they are ready-made means that they are already well written and compiled. So what you simply have to do is to call their execution in your program and they do the job for you. They're also called engines because what you do is that they work in the background of the application. So those engines can provide you different kind of features which are very hard to write in your program, but if you want to use them, you can specifically tell the system to put those engines in your program. Okay, there are sometimes also tools as well, for example, for development, configuration and content, and these tools are also part of framework. These tools are for development, like if you are using them for your program, then they can provide you some code, some executable code. And for configuration, if you have studied configuration in software engineering, basically it gives you control to keep track of the changes in your system. So whenever you modify the system or you bring in some new change in it, or if you add something to it, that is recorded and kept in configuration list. That configuration list is generated along with the application execution, and you can access it and you can put some new data in it. And if you don't want to put data yourself in the configuration list, the framework does it for you. So framework has got a tool which keeps track of all the changes. If I give you example of these changes, you must have seen different versions of a software. So basically these versions tell you that there are modifications in the software, and all these versions are well documented. They are kept in the configuration list, that what were the new things in a newer version and what has been modified from the previous versions and when that modification took place. So it keeps track of all the information about a modification. Similarly, configuration example is the release of different kind of these software comes with releases. So first release is always called alpha release, which is basically for testing the system within the organization. For example, in a software house, if an application has been built, then you call it alpha version of that software and you give it to the staff in the organization, and they test it for any errors, for any bugs, and then they give their feedback, and according to that feedback that software is modified and you make a beta version of that software. So after the alpha, you release that beta version to the public or to the users which are the actual users of the system. And then you keep that feedback system along with the beta version, and the users give you feedback, and then you modify the system according to that feedback, and then you release the final version of the software. So this is also part of configuration. So version control and release control are two main features of configuration. So what these frameworks do for you is that they keep track of that configuration, they do the configuration for you, and they do everything which is related to change on the background, in the background of the application. So you don't have to worry about it, and you can simply take the reports out of the system that what changes you made to your software. Similarly, there are tools for contents as well. Like if you have got an application of a website, and that website has got some different kind of contents in it. For example, if you have got an online shop, and on that online shop there is information about products, information about the sale which you do online, and information about the inventory of those products as well. So these content management tools, what they do for you is that they make the reports of these different contents, and they keep track of these contents, and they let you know if you want to have a report monthly, weekly, bi-monthly, fortnightly. They generate this kind of report for you. So frameworks also have got these kind of tools which assist you in the programming. Okay, often evolved by developing many applications of that type and reusing code more and more. So basically, frameworks also do reusability for you. For example, if you have developed a system and then you are working on a different system but it has got some features similar to the previous system, what you can do is you can take the exact code from the previous system, you can take the exact the methods or classes from the previous system, and you can use them as they are because they are executable and they have already been compiled, they have already been checked for errors, so you can use the code as it is in the previous systems. So this is called reusability of the system, and of course you can use the whole system and you can make it a part of some other system as well in the frameworks. So these were the features, the main features of the frameworks, and there are some characteristics of the frameworks, which is of course reusability, which I just told you. And then there is extensibility. I told you that as well, that what you can do is that you can add something onto the framework, you can add some features to it, you can take some features from other frameworks and can append them to a particular framework. And also these frameworks are extensible in nature, like you can override the code which is written in these frameworks, you can override the libraries and the APIs, and you can also modify the engine code in the frameworks. And so this is called internal extensibility, but there is external extensibility as well, which is that if a new framework arrives in the market, you can simply take the new one and can append it to the previous framework, and it will start giving you features of the new framework as well. Okay, there is another characteristic of it, is called inversion of control. Inversion of control is like you have got full control of the system if you are using a simple program, or if you are using Java IDE, that you simply write the code and whatever is written in the code, you have got control on that, and only that piece of code is going to be executed. But in frameworks, framework also has got some control on your code. That control means that during the runtime they can append some new code to it, or they can put some inline code to it, or they can call libraries and APIs for you, or they can execute some kind of engine or event in the background for you. So this is called inversion of control, which is not provided by simple IDEs. So you have to use framework which does it for you. And you must have seen some application with threads, like there are multiple things that are running in an application at the same time, which is also called multitasking, and that's controlled by multi-threading. Multi-threading is also part of frameworks, and they can do it for you. They can run multiple frameworks in the background, and you can invoke them if you like, but if you declare in the beginning that you want framework to do it for you, then they will simply run in the background and you will not have to worry about them, and they will do their functionality for you. Okay, if we look at some examples of framework, this is a typical framework of making web applications. So what it is doing for you is that it has got, if you look at this window, it has got all different features for you, and you can select this feature according to the application you are developing. You can put some new code into it, and you can add new stuff to it, and this is just like drag and play kind of a technology, that in which you can simply drag some already executed code into your system, or if there is any API developed already in there, you can simply call it and use it in your program. So this is a typical web application framework. And there is another one, GUI toolkits. Now GUI stands for graphical user interface, and it has got a lot of toolkits which are available with some of the frameworks. And GUI is basically the use of the mouse or the keyboard, or the use of some graphics which can show you different pictures of the stuff which you have got, or the control which you are going to put in it. You can also add some hyperlinks in it, buttons in it, dialog boxes or edit boxes. So these are all part of GUI toolkits. If you look at these, some of the fields in which you can put the password and the login details, any date or any authentication field. So you have got also buttons, menus, and the scroll bars. So this is a GUI toolkit which is provided by the framework, and you don't have to write code for it. Well, it's if you adopt to write code for yourself, then of course it provides you an IDE in which you write the code for GUI yourself. But if you simply want to use the already executed code of some GUI feature, then you can import it and use it in your application. So this is a typical example of usage of a GUI. You can see that there is a plain text field in it, and there are different kind of features which you can use, like menus, sub-menus, and you can also make frames. In one frame you can do different tasks, in other frame you can do entirely different tasks, whatever you want and the way you want to make your application look like. So you have got full control on it. So what framework does it for you is that they do it for you from the libraries, from the engines they have got, and all the applications which are part of these frameworks. Okay, so if we talk about extensibility of the frameworks, so what does it mean? I told you extensibility is if you're extending any framework. Why do you need it? That sometimes it is intended that a particular application which could not be fully developed by a framework which you have chosen, so it is intended that you add some other features to that framework. Now the framework has been provided by the vendors, but they are open source frameworks. And what you can do is that you can simply have another framework and extend the previous one with the new framework or some features of the new framework. So all frameworks can be extended to cater for application specific functionality. A framework is intended to be extended to meet the needs of a particular application. The common ways to extend a framework is that you can do it by subclassing, by overriding methods, and implementing interfaces. Subclassing is the same thing which you do in the inheritance, that you can subclass some of the parent classes which are mentioned in the framework. You can make new child classes from those classes, and you can also override their methods by adding some more functionality to those methods, and of course implementing interfaces. I think we have already covered these interfaces, so you know how to implement interfaces. So if you have because it's an open source and you can look at the class structure of a framework, so you can see that what kind of different interfaces are being provided by that framework. So you can simply implement them with new classes, and you can implement it and adding with the addition of some new methods in it, and of course with the addition of some new functionality of the same methods which have been given in the interface. And you've got plugins. Frameworks can load certain extra code in a specific format. Plugins are also basically executable events which have already been executed. The code has been fully written in it, and what you should do is that you can take a plugin and you can add it to your framework, and it will start working. It's just like engine or APIs which you use in your system, but in APIs of course you have to write some more code to it to connect it to your code, and engine does it for you like in the background. And so plugins are similar to that you can load a different kind of plugins and put them in your framework. For example, if you want to load a plugin of a different kind of language, if you are working in ASP.NET but you want to add C# as well in your code, you can simply add the plugin of C# in your framework, and it will give you the ability to write code in the C# as well, and then your ASP code and C# will run in parallel. And within the framework language, you can also do the subclassing and overriding of the methods. You can implement interfaces, and you can register event handlers. Now, event handlers are already part of the framework. If you remember from the previous lectures, we covered exception handling, that is event handling. And there is, other than exception handling, we have got some other capabilities which you want to put in the software. You can make them events, and those events you can write code simply for them, and it will be automatically called and will do the functionality for you. But you can also register some new event handlers in your code, and how you do that I'll show you in later slides, and I'll also give you some examples of some event handlers. So basically, this is the way you can extend a framework, and this is what is called extensibility of framework classes. Now, inversion of control, basically a framework employs an inverted flow of control between itself and its clients. When using a framework, one usually just implements a few callback functions or specializes a few classes, and then invokes a single method or procedure. But the framework does the rest of the work for you. It invokes any necessary client callback or method at the appropriate time and place. So basically, it does a lot of job for you, and it calls the methods from libraries, from APIs, and do it for you. You simply have to mention what kind of libraries you want to put in your code and what kind of different callbacks you want to have in your system. So the framework takes the control of all those methods which are written in other classes or which are written in other libraries, and they do it for you in the background or in parallel. And you can also do it explicitly by writing their code in your program. But if there is a functionality like that available in the framework, then one should take advantage of it, and you can declare the different kind of functionalities or features you want your system to have before the system is built, and then this inversion of control feature will take control of it and will do it for you. To give you some examples of inversion of control, you must have seen Java swings and AWT classes. What they do for you is that they write code for GUI, for all the graphical user interface constructs which you want to put in your system. For example, if you want to have buttons or menus or some menus or the frames in your application, you can simply call some piece of code of swing classes, and they run the code for creating that button or creating that menu for you. So you don't have to write everything in it. You don't have to write how that button should be made or how that menu should be made. You simply have to provide the features which you want to put in the menu, or the text which you want to put on the button, and the functionality which you want that button to do if it is pressed. And similarly, we have got AWT classes as well, which do the same kind of a job. So these are Java's inversion of control if you're using Java framework. So they have a huge amount of code to manage the user interface, and there is inversion of control because you start the GUI framework and then wait for it to call your listeners. So you simply call them and you call the methods, or you simply provide them information to make that kind of a feature in your system, and then you wait for it. It does that job for you, because for even creating a single button, there are like more than 100 lines of code which you have to write. But if you are using swing classes, you just have to mention the implementation of swing classes in your system, and then you have to write only one line of code which tells the system to create a button, and then you tell it that what kind of feature or what kind of action that button is going to take within just one line of code, and this swing classes do it for you in the background. A traditional, if you look at the difference between the traditional program execution and the framework program execution, then if you look at this diagram, if you are writing a code in the traditional way of programming, then an application calls an input-output library routine. Here the application code runs here, and there is a library code. You have got, of course, you have got access to the libraries. If you have used C language or C++ language or any previous languages, then you must have seen that they also provide some kind of libraries, some math libraries, some graphic libraries, and you can use the same kind of a feature which frameworks do for you. But the difference between them is that application calls a sort routine here during the application code. The application has control over the execution flow, calling library code when it needs to. But if you look at the inversion of control, the framework has control over the execution flow and calling application code for a application specific behavior. So here you have got the application which has got that control. Control means that in an application, whatever is written, the compiler goes line by line and it does that job which is written in that lines, and it doesn't have anything else to do. I mean, when the code finishes, the compiler leaves the system. But if you look at the framework, it has got a lot of features in it. So there is application code which you have written, but that application code doesn't have all the control. Rather, the framework has control over the execution flow. It calls different applications which you have mentioned in your system, and it calls different code and does different application specific behavior for you. So if you look at this example, there is a framework generates a Windows resize event. Now this framework is generating this window resize event. Now this window has been created by the framework. You have not written the code to create this window. You have not written the code like how this window should look like, whether it should have these 3 buttons at the top, there is a button at the bottom, and you have got a message box, you have got a text box, and what is written on top of it. You have not mentioned anything at all. Rather, you just have mentioned that you need a window to open during the execution, and that you have done by writing a single piece of code. But you have obviously extended the swing class or AWT class in your code, and that class tells the framework to invoke invoke this class which makes this kind of a window for you. Similarly, this framework code, we have got framework generates a paint level. So if you want to paint any window which appears during your code, and the framework has got the code for it, and it will do it in the background, and the window which you will see on the display screen will have that paint on it, which is painted by the framework as also. You don't have to tell how that paint should be done. Framework generates a button click event. So here again, you are not writing any code for button. Rather, a framework has generated a code, but it also asks you that what kind of event you want this button to do. So you can simply mention that kind of event, and they also give you options. In some of the frameworks, they will have a menu, so you just have to select the kind of functionality you want a button to do, and that functionality will automatically be called from the libraries, and the framework will embed that kind of a code behind the button, and whenever the button will press, that code will be invoked. So basically the main difference is that in traditional program execution, all the control is with the application code, and whatever you write in the application code, only that behavior runs. But if you look at the inversion control of the frameworks, that frameworks does a lot of things for you, and it does a lot of extra work which you don't write in your code. It does it for you by calling the libraries and the engines and plug-in functionalities. Okay, there are some new examples of inversion of control. For example, Java Applets. You must have heard about these Java Applets. They have got already executed code in them as well, so they can create new windows for you. They can create new kind of functionalities for you, and if you want to put some mathematical thing in it or some graphical one as shown in this picture, and so framework does it for you. You simply have to write the kind of classes you want to put in your code. So you simply have to extend them and import them in your system, and frameworks call those kind of applets. For example, in this particular applet, these are the typical examples of the methods which are found in an applet. For example, there is a start applet method, there is a paint method. It will give the colors to the applet, and a stop method and a destroy method. Now you can also customize them by overriding them and by adding new functionalities to them, or if you want to change the functionality which these methods have got, you have got the capability to do that as well. And there is this initialization method which runs in the beginning when that applet is initializing. So if you look at it, this is a typical example of the working of an applet framework, and it is basically for web browsers, and it generates different kind of codes for you. And if you look at it, that you are not calling these methods, rather these methods are being called by the applet. Like there is this initialization method, and that is part of the framework method. It's not written in your application code. Similarly, if there is a start method for paint and for the applet, and the paint method for the applet, stop and destroy methods, they all are being called by the application framework. And what they have done is that they have created these two windows for you. They have created this tic-tac-toe game for you, or they have also created these kind of graphical images which you want to put in your web browser. So applet are also, executable methods, executable functionalities which have already been written. Their code has been written, and that is attached with the framework. So you just have to tell the framework what kind of applet you want to use in your system. Okay, now until now we were talking about the generic frameworks which can be used in any language, and you can deploy them in any language, and these were the general features which every framework has got. Now we will focus on Java frameworks which are attached with Java technology, and they are provided with all Java IDEs, and the new IDEs which I have also recommended to you, like Eclipse or JBuilder, they have got this capability of frameworks. You can either write your code on your own in the old style, or you can call the Java framework and you can write code in it. You can write different kind of features which you want to call that framework to do for you. So Java framework are not that different. They've got all the features which a general framework has got. They are the large bodies, usually with many classes of pre-written code, to which you add your own code to solve a problem in a specific domain. In Java technology, there are so many frameworks that helps the programmer to build complex applications easily. For example, there is a GUI framework which is attached with Java Swing and AWT class, as I told you before, and there is a collection framework as well, which is a part of a library. It is a unified architecture for representing and manipulating collections. If you remember from previous lecture, I showed you some examples of collections. One of them was list, and there is a set, there is array, there is queue, and there is a sorted sets as well, which are part of the sets. So similarly, there are maps which have got sorted maps. Now these collections, basically they are used to keep data of the same behavior. If you want to make a collection of objects, you want to make a collection of some concepts, then you can call list or array or linked list. There are different kind of collections which are available, and these are also offered by the collection frameworks. Collection frameworks will be used when you have got a data which has got which you want to keep in some kind of array, or which you want to make some kind of a set for that data. So you can use this collection framework, and you can use the libraries which are attached with the framework. So in those library, all the features of these different collections have been written already. For example, there is code for list. I showed you some examples before that you can call a collection of list, and then you can add either objects to it or any kind of items which you want to keep together in one collection. Okay, so it contains interfaces, implementations, and algorithms as well. Now the collection framework does not only have collections related code, but they have also got interfaces, implementation, and algorithms. They have got classes which you can either implement or you can extend, and you can override their methods to change the collection according to your own needs. Now there are some collections which are type specific, and you have to mention the type before you're declaring them. And if you want to declare a new type, and which is not part of the code which is written in that framework, so what you can do is you can override that method where that code is written for typesetting, and you can add the new type in the framework as well, and then you can add the similar type of items in that framework with new type. So these were the examples of Java frameworks, and two more popular ones are Java Swing and AWT class, and the collection framework and libraries. Okay, if we talk more about Java collection frameworks, what they do is that they reduce programming effort. They concentrate on the important parts of your program rather than on the low-level plumbing required to make it work. So what it does is that you don't have to mention what kind of list you want to use, or how that list is going to store the data, how that list is going to give you the data when you require it. And if you want to display the data, that can display it in different formats, so you don't have to mention those formats. Rather, those formats have already been declared. What you do is that there are menus which are provided by these frameworks. So for example, if you have made an object of a collection list, and then that list object, if you just write for example, let's call it L. So if you write L dot, it will give you the sub menu which will have all the features which are related to that collection. So you can simply those feature. One of the feature could be adding. So that adding feature would do where it would add all the elements of that list in that collection. And there is one remove, there is one destroy, there is one display. So these kind of features are already written in it, and the code has already been written for you. So what you have to do is you simply select it from a menu, and that framework will call that feature for you, and it will do that functionality for you. And what it does for you is that it increases program speed and quality. So it also reduces a lot of number of codes, so your program becomes shorter and it becomes more understandable and reusable as well, because it doesn't have a lot of code in it. And also it helps with documentation. So, and it also helps with the speed as well. The speed means that if you write your code yourself, and if there is if you're not calling the library, so that code will be a very huge code, and it will take it time to run that. But the code which has been provided by frameworks, that has been written by experienced programmers, experts. So those codes are very efficient, and they have got those kind of logics or those kind of features in that code that makes it quick to run. And so the overall system becomes speedy if you use these kind of framework attributes in your system. And it also provides high performance, high quality implementation, and the useful use of data structures and algorithms. Now the data structures which you have to implement, for example, heaps, sorted arrays or graph trees, sorry. So you don't have to mention these data structures in your system, because these data structures have been implemented in the code for you. Okay, fosters software reuse. New data structures that conform to the standard collection interfaces are by nature reusable. The same goes for new algorithms as well that operate on objects that implement these interfaces. So reusability is also enhanced. We have talked a lot about it. Now if you compare framework with libraries, so what is the difference between these two? Framework uses your code because it is usually the framework that is in control. It means the framework controls the sequence and logic of the operations and calls your code to provide certain details. Okay, and you make use of a framework by calling its method, inheritance, and supplying callbacks, listeners, etc. But note, although sometimes large libraries are referred to as framework, this is probably not the most common use of the term. So what it means is that libraries are basically collection of the code which has been provided by the framework. The framework itself is the tool which calls those libraries for you. So sometimes the big libraries are also called frameworks, but they are not, because framework does not only call libraries, it does not only provide you applets or applications, but also what it does for you is that it runs some behavior in the background. It runs some event handlers, it runs some engines for you in the background. So there is a big difference between framework and libraries. So a framework is a full-fledged tool. It has got a lot of features in it, whereas a library is just a static library which has got methods which you can use, which you can call, and if you don't use them, they don't do anything for you, or if you don't call them, they don't do anything for you. You have to explicitly make the call for them. But framework can run a lot of features in the background for you even if you don't mention it, because according to your code, for example, if your application is web specific or if your application is distributed, so whatever the features you require for distributed programming, for example, synchronization of the threads, or for example, if you have got multiple clients working on it, so those kind of features are handled by the framework. So it is a tool which does it for you. But if you look at a library, that is just a static storage of code which is there for you to call and which is there for you to use. If you don't use it, it doesn't do anything for you. Okay, advantages of using it is, of course, reusability, which we have already talked about, and a higher level of abstraction. Now, how does it provide higher level of abstraction? Because you don't write a lot of code in it. Okay, so you simply mention the classes which you need, and you don't put a lot of detail in it. If you remember from the lecture where we discussed abstraction in detail, that abstraction has got, it just gives you an overview of the system. It doesn't go into the detail. It gives you basically a white box view of the system, and black box view of the system, where you just can see what are the different classes which are in front of you. You can't see the detail which is written in those classes. So if we look at the framework, it also increases the abstraction level, because you just write the classes which you are going to implement in the system. You don't write the classes which will provide you some extra functionality, or which will provide you some quality related features in the system, because those are handled by the framework. And it also doesn't show, if you have got some GUI features in the system, you don't have to write the code for that GUI. So what you are doing is you're just calling or importing the GUI code in your program. So basically this is a kind of abstraction, because you're not going into the detail how that GUI features will be implemented, how those GUI features will be generated during the runtime. So frameworks provide a standard working system through which user can develop the desired module of application or complete application instead of developing lower level details. Developers can devote more time in developing the software requirements, And once you have got these kind of capabilities, once you have got the control on the framework that it will do different kind of it will generate codes for different kind of GUI features for you, then you can concentrate more on the requirement implementation, because that is more important. As I told you before, that the main phase in software development life cycle is a requirement gathering, a requirement analysis, and making sure that all the requirements have been implemented in the system. So requirements are more important than putting any colorful buttons in your system or putting any colorful text boxes or dialog boxes in your system. So as long as all the requirements have been implemented, your system is fine. Then you can of course change the look of it after the system is complete. You can add colors to it, you can add you can do different kind of formatting to it, you can add some new animated features in it. But if the requirements are not fully implemented, then your system is not complete. So once you have got the capability of implementing those extra features automatically, then you can concentrate more on the implementation of requirements in the system. So that will eventually make the system more efficient, or it will also please your customer as well, because if all the requirements have been implemented, then the system will run efficiently and the system will be complete. So, and it also reduces the maintenance cost as well if the framework is maintained by someone else. So the framework has been provided to you, and it has got all the features in it, even because they are bugs free, they are error free, so you don't have to worry about them. So you just have to look at your system. You have to test your system, and if there is some new modification you want to do, if you want to introduce some creeping requirement in it, some new requirement in it, so what you have to do is you can simply write the code for that requirement in the system. You don't have to worry about the features which are attached to it or the applets which are attached to it, because they are already there, and you can add some new features just by writing one line of code. So the maintenance also becomes easy with the use of framework, and the modification also becomes easy. And if, at the end of the day, your system becomes more consistent because you have got control on the application. You're not worrying about non-functional requirements which are being implemented in the system with the help of the framework capabilities. Well, these were some of the advantages of the frameworks, but there are of course disadvantages as well, that it can lead to code bloat. Now, what is code bloating? Code bloating is that when you have got a lot of features in a software which you don't want to use. For example, a famous example which is given to make the code bloating understand is of MS Word. You must have seen MS Word, that it has got so many features that even if you keep using it for a long period of time, you won't be able to use every feature of that software. So it is a bloated software because there are so many features which are not required by everyone. So frameworks are the same kind of applications, they're same kind of tools, that they have got so many features in them, and as a result what happens is that a lot of code is run or is executed which you don't want to run. And it can take more memory, of course, in the RAM, because it's a heavy framework, it's a heavy software which has got so much code in it, and that code is of course loaded during the execution. You don't write it, it can save you time, but as far as system is concerned, your system will suffer because it will have to load a lot of code from tools, APIs, event handlers into the RAM. So there is some overhead of overusage of RAM, the memory, and it also it may need to use several frameworks as well. Sometimes you have to extend this framework, you have to use several frameworks at one time, so that can also put more load on the RAM, and it can also run those features which are not intended. Okay. So cost of learning a framework. Of course, frameworks are not easy to learn. It can take a lot of time to understand what are the functionalities which are provided by a specific platform. So you have to get a proper training to work on a framework, and you have to spend more time in assessing the concept, the functions, and its uses in developing the program. So it's not as easy, like even if you have got a full grip on the language, for example the Java language, even then to understand Java framework you will have to spend a lot of time to look at its feature, what are different functionalities it's providing, how those functionalities can be used, how the classes can be overridden, what kind of different functions, methods which are available in that classes, what are different interfaces and classes there which you can inherit or which you can implement in your system. So you have to spend a lot of time to understand the architecture of the framework and all the tools and capabilities which are provided by the framework. So of course it can cost a lot of learning time as well. Licensing cost, of course they are commercial, so you have to purchase these frameworks. A generic one-size-fits-all does not work so efficiently for any specific software. There is need to extend framework with specific code to develop any specific software. Of course there are generic kind of frameworks available in the market. For example, if you want to develop a website for an accounting system, now that framework will only provide you features for developing an efficient website, but it will not provide you extra features which you require to implement an accounting system. So for that you will have to have some features from other frameworks which can handle accounting related features, and you will have to extend this web specific framework with those features. So so there are generic frameworks available, they're not specific frameworks, so you have to customize them, which is of course another overhead of using framework. After frameworks, we're gonna read GUI programming concepts, but that's what we will do in the next lecture. So our lecture about frameworks ends here, and before I end the lecture I'll recap what we studied today. So after looking at the implementation of the classes, objects, interfaces and inheritance and other features which are available in Java programming, we looked at framework. Now framework is a tool which can provide you a lot of features which you don't want to write in your program, or which are extra functionalities of the system which you are implementing. So you don't want to go into the detail, you don't want to write many features in your system, and you would rather import those features and you would rather someone else to do that for you. So framework is that kind of a tool which does these extra functionalities for you, and it saves you a lot of time, it saves you a lot of energy to write that code. And so there are APIs which are provided by the frameworks, there are libraries which have got different classes for different purposes. And for example, if you are putting mathematical equations in the system, if you are putting some account related features in your system, and there are specific classes for them, and there are methods written for them, and of course you can implement them, you can extend them, you can override them. There are applets available which can run applications in the background for you. There are event handlers which can run different kind of events, and they can also handle any kind of exception which can arise in your system. And there are APIs which can do specific tasks for you. For example, if you want to put some GPS related feature in your system, there are GPS APIs available, so you can simply call those APIs and they will do it for you. So you will simply have to connect that API to your code, so you don't have to write a lot of code for GPI features. So these are the framework, and of course along with all these advantages they have got, there are some disadvantages as well, because they're very heavy tools, and they take a lot of space in the memory, and they are hard to run, and they are bloated as well with a lot of features which you don't use all the time, but those features run in the background, and that can be an overhead on your system. So these were the advantages, disadvantages of framework. We talked about general framework. We also talked about Java framework. So in the next lecture, we will discuss some one of the typical framework which is commonly used in Java. That's called Swing and AWT. So we're gonna talk about different concepts related to these frameworks in the next lecture. तो यहाँ पे ख़त्म होता है आज का लेक्चर. वी कंक्लूड दिस लेक्चर टुडे एंड वी विल मीट इन द नेक्स्ट लेक्चर विद न्यू टॉपिक. तब तक के लिए इजाज़त दीजिए. अल्लाह हाफिज़.